In section 3B, we're going to talk about putting numbers in perspective. You probably have come across extremely large numbers in reading the internet or reading a textbook, for example. For example, the U.S. debt is $17 trillion. It's hard to wrap your brain around, like how, we all know that's a lot of money, but how much is that? So there are some techniques, though, to help you put some perspective on on numbers that large or really small numbers on the other end of the spectrum, to figure out, to make it a little bit more meaningful to us. Some of those techniques that we'll look at is using estimation or an order of magnitude prediction. That'll probably be the newest thing to you, and that's where I'm going to spend the most of my focus in this video. The other two topics we've already talked quite a bit about. Make a comparison of something. Make a comparison of some number to something that's a little bit more tangible. I'll briefly point that out to you on the next page. And then lastly, we've done quite a bit of this. Convert the units of one number to another unit, so that helps put it into perspective for us a little easier. For example, if someone tells you their weight in kilograms, I don't know, what that. I really, I don't have a good reference value for that. But if I convert those kilograms to pounds, then hey, okay, I know what we're talking about now. That sort of thing. All right, so let's first start with that estimation versus order of magnitude. Estimation is just simply, working with nice, easy rounded values in your calculations. Order of magnitude, though, is specifies a broad range of values, usually within 1 to 2 powers of 10, such as in the 10,000s or in the millions. A couple of examples here. When astronomers say that the number of stars in the galaxy is of order 100 billion, that means that the actual number of stars could be anywhere between a factor of 10 of this number, essentially 10 billion or 1 trillion. However, whenever we use the phrase that the U.S. population is on the order of 300 million, it implies less variation. So of order is applying more variation. On the order of, we're fairly close that it's around that 300 million mark. In the example just below, this is an example of an idea where things are going to vary from person to person. Which is greater, the amount you spend in a year on transportation or the amount you spend in a year on food? If you're a family of 4, then food is going to be a big factor, as opposed to a single person living by themselves. It's not going to cost them nearly as much. What I'm going to focus this, though, on is that, okay, if one person feeding themselves, one person, one car. Okay, what are we kind of looking at cost-wise here? So, for example, let's say food-wise, then we're looking at 3 meals a day. And then, of course, there are 365 days in a year. And then that way, at that point, days have canceled out. And so then I've got meals per year. I need to get a cost in there. So roughly, this is where you want to estimate. I'm going to say roughly $8 a meal. Some of you might say, hey, that's high. Some of you might say that's not high enough. So I'm gonna shoot there, $8 for every meal. That way, you can see then what has started to cancel out on me. I have now gotten rid of my meals, and I'm left with money per year. And if I multiply straight across, as you've seen me do numerous times now, $8,760 per year on food. Okay. Transportation, as you can imagine, there's quite a bit more involved. Gas, for example. So we'll start there. We would say, okay, let's say we spend on average $40 per week. And we do one fill up a week. So then we'll say, okay, and there are 52 weeks in 1 year. So gas-wise, 2,080. But as you know, that's not all that's encompassed whenever you have a car. You also have to do routine oil changes. So I'd say oil changes running roughly about $30 a pop, and let's say you'd have around 4 of those a year, so $120 for oil changes. We have to pay taxes on our car. That of course can vary. I'm going to say a good estimated amount is about $100 per year. You have to pay insurance. Insurance for the entire year, one car, probably about $800. And that, of course, that varies from person to person, depending on how many accidents they've had, things like that. Maintenance, you might need new tires. Something might go on your car, and then you had an unexpected expense. I'd say $200. I'm putting all these in per year. Then, if your car's not paid for, you've got a car payment. And I'm going to say, roughly average car payment $300 times 12 months, so $3,600 per year. Total then, after adding all of these values together for a car, it's supposed to look like total, would be $6,900. So you can see the example here that I'm showing that, food would cost more. Look down at another example. It says, make an order of magnitude estimate of the total annual spending on ice cream in the U.S. Some may think, I have no idea even where to start. Say for example, well, we know that we have roughly 300 million people in the U.S. So take those 300 million people, and let's say that they each have maybe one serving a week. And then if they don't even have, and that sort of, some people obviously have more, some people don't have that many. So let's say that they end up with about 50 servings per year. These are the kind of problems that are probably going to be a little bit more challenging for you because they're going to vary a little bit on you. You can have your answer can vary from mine, okay, just as long as it's on the order of being close to mine. And then we'll say roughly that those servings are going to cost us $2 for every serving. You can see as far as my units canceling out that your calculator then, I bet in many calculators you're probably getting this 3E10. What that means is a scientific notation, so that means 3 times 10 to the 10th. And so that's taking that 3, and here's your decimal behind it, and moving that decimal 10 places to the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And inserting all of those zeros in between there. 6. Go back and put my commas in. Let me just write it over here. Should be 30 billion. Of course, you can write it with all the zeros, or you could just write 30 billion. And then lastly, in the last example, it says make an order of magnitude estimate for the total amount of gas that will be used by all Americans this year. I'm not going to use the full 300 million people, because of those 300 million people, you have a substantial amount, that do not drive. So I'm going to say like 2/3 of the population are driving individuals. So 2/3 of means to multiply. So 2/3 of 300 million. After I do that multiplication there, I'm talking about 200 million people. And let's say average tank size is 15 gallons for every one fill up. And let's say that you have one fill up per week. And there are 52 weeks in a year. So now at this point we can see the units that have canceled out on us, the Phillips, the weeks, and we can see then, okay, I've left with how many gallons per year have been used. After you do that multiplication, you should be getting 1.56 times 10 to the 11th. So with that said then, what that means is that I have that 1.56. I'd move that decimal 11 places to the right since that exponent's positive. So go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I'm inserting zeros in all of these places now. I come back and insert commas. So I'm really talking about 156 billion gallons. So 156 billion gallons of gas. Okay, we'll skip on to the next page. I'm not going to work anything out on this page, just going to talk a little bit about what these first couple of examples. The first couple of examples are trying to put a reference on, like for example, 1 billion and comparing it to a million and a trillion. And likewise, in the third example there, it's wanting you to, that $17 trillion of debt. What would that mean then in terms of debt per person if there are 300 million people in the U.S.? So definitely take a look at that. And the last few examples here are, like I told you, that you could consider changing the units. So here they talk about 7,500 tons. We all know that 7,500 tons is a large amount of it's a large weight, but how much is it? So likely then a good unit to express it in would be to convert that to pounds. So that would be the focus of these last few, and I've shown you quite a bit about converting units to this point, so I think you'll be good on your own with the solutions key. Thanks.